Hello everyone and welcome back to New Horizons. So we finally managed to address the applied energistic system and we're now able to feed it more power than it consumes. And you guys know what that means, right? That means we can expand it. So today we're going to set up all kinds of automation, expanding our applied energistics autocrafting capabilities. We'll see how far our resources take us. We are also going to develop this room through here, which currently only has one machine inside. Well, two if you count the fluid solidifier. But yeah, we're going to set up autocrafting for all the Gregtech components. Well, maybe not all. That's a little bit ambitious, you'll see. But yeah, we want to start to get some autocrafting on the go so that we can reduce the amount of manual crafting, which we are still doing at this point in the game. I mean, what are we on here? Year 14, day 187, with 939 hours played. Yeah, I've played this game for a while. And you know what? I think we're approaching the time in Season 1, which was 960. So we are quite a bit slower this season, but you know what? I'm having a lot more fun. But that is certainly not going to stop us today. A lack of circuits, on the other hand, might be a limiting factor. But yeah, as always, we have a lot to get through today, and you know what? I think it would be helpful to get some sort of a game plan. So the question we need to ask ourselves is, which of these machines do we want to replace? Ideally all of them, because we have to manually fill these. And we'll replace them with faster equivalents, which applied energistics can fill. And the end goal of all of this is to be able to open the terminal and request almost any item that we want. Okay, first of all, there is no way in this universe we're going to be able to upgrade everything all at once. So both for my own sanity and to make it a bit easier to understand, we're going to do this in smaller chunks. And I've went ahead and compiled a list of all the machines we need to automate. And they are the extruder, the bending machine, the forming press, the wiremill, the mixer, the polarizer, the lathe, the laser engraver, the chemical reactor, and the assembling machine. We're not finished yet though. Slightly further down on the list is the cutting machine and the circuit assembler, which for us we already have inside the clean room here. In fact, we have two cutting machines and two circuit assemblers, and these are the only two machines in our base which currently can autocraft for us. We have some circuits here and some wafer recipes. These specific recipes though need to be done inside this clean room, and there are ways to get around that, but because our list is so long, we are going to leave these where they are and focus on some of the other items on our list, which again is still not finished. At some point, probably not today, we'll also add a blast furnace, an autoclave, a chemical bath, a compressor, a macerator, and an alloy smelter. Yeah, honestly, there is a lot to get through, and it's a really difficult part of modded Minecraft, especially tech packs. The transition between manually crafting and automated crafting, it's not an easy thing to do, but we are going to certainly tackle it head on. And we are going to start with the bending machine. There is a multi-block version at this point. It's IV, so it doesn't look too bad. The casings take some more of this Tantalloy 60. Other than that though, it should be doable. On the tooltip, it also mentions it can be used as a forming press. So we are going to craft two of these. If we're going to craft one, we might as well craft the other since we need a forming press anyway. And I think you can do a cool trick here, control scroll wheel, and you can increase the number in your pin list, so we'll need two industrial material presses, which again are for the bending machine and for the forming press. We have a few here at HV. We've been using these for some of the applied energistics, printed silicon, logic circuits, and so on. Over the last couple of episodes, I have been cutting out a lot of crafting, so a lot of these things maybe you're not so familiar with at this point, but it's going to be easier to explain after they're built. The other very easy thing we're going to start with is a wire mill, which obviously is used for wires, and there is a multi-block version. It is IV. It's a bit of an awkward shape, but again we're going to add this to the pin list. And the final two machines we'll add to the initial round of crafting is the polarizer. The multi-block version of this one though is the large processing factory, and this is just not going to happen. I think it's this arcanite, yeah, molten arcanite. That is not going to happen. So for now we're going to go for the single block. And the final machine we'll craft in the initial round is the lathe. But again, for the lathe, we need to go for the single block to start off with. And just on these 5 machines, our pin list is already very expensive. So with that, I think we have enough to get started here. Let's get crafting. Alright, so the first thing I wanted to do is batch craft some energy hatches. As a baseline, we'll start all the machines at EV, and while in some cases the recipes might be IV or above, we can address those as they come up, and I think it will simplify things a lot if we start all the machines at the same voltage tier. EV seems to be a good starting point, and it will cover most of the basic machine processes in the game. So I made us 12 EV energy hatches. Next up, I wanted to work on crafting the first of the multi-block machines, and I started with the Wiremill. After quite a while of crafting condensed down into a short period of time, as is becoming a theme in this episode, I then moved on to the 2 industrial material presses for the forming press and the bending machine. And this was lots of GT++ alloys in the alloy blast smelter, a handful of expensive IV circuits, and as always plenty of Gregtech components. I also mixed in crafting some of the other miscellaneous components we would need, like energy cable, transformer, interfaces and fluix cable. Alright, well that was a lot of crafting, but I believe we're ready to get started here. I do have a question to you guys though. Do you normally craft everything you need all at once? Or do you craft as you go? Personally, I'm actually undecided on which way is more efficient. But yeah, as you can see here, I did experiment with some of the colours. I went with orange stained clay, and also magenta stained clay. I think I'm leaning towards the orange though. But orange is the best colour of course, so I think this room is going to be orange. Other than the machines though, the other important part to autocrafting is the CPUs. Right now they are currently in a temporary location here, but ideally we move them down to the purpose-built room on the bottom floor. We kind of left with a dilemma of how we're going to plug this in to the main controller. We need a clever way to send the wire from this level down to the bottom down here. And I think I've figured it out. We are going to go through the wall here, somewhere in this location. We should hit the pillars. Yeah, these 2 massive pillars here, we're going to send the wire straight through the middle. So we'll dig out all the red blocks. The only flaw with this idea is that this is the subnet connection right here. And ideally we send a P2P connection to our main controller, because the P2P for the terminals is here. That's going to be a lot of rewiring. I mean, we do have 4 spare channels on this line, so I think for right now, until we do the rewire of the controller, yeah, for right now we're just going to extend a line from the dense cable. And so we can only have 4 CPUs for the time being, but again, they are multi-block structures and we can upgrade them. And this wire right here, if I'm not wrong, should put us in the purpose-built wiring tunnel that we built. Oh yeah, look at that, perfect. You could not ask for a better spot, this is absolutely perfect. Yeah, and then from here we can run it along to all the crafting CPUs. The first one we'll put here. 2 16K crafting storages, 2 coprocessors. We also should have some spare components here, right? Yeah, we have some spare 16K storage components, which we got from loot bags, I assume. And also some more engineering processors. We can use these to create some more crafting storages and coprocessing units. Kinda slow recipe here. In the meantime though, we can craft some facades, which we need to cover up the cable with ISM. Just surround the block with some cable anchors. And this way we can really easily cover the cable in the pillar. And it's like nothing is ever there. Sometimes it's nice to actually expose the cable. I think in this case though, we want to keep it red. I love these things. They're awesome. And of course we cannot forget about the wiring tunnel here. We have to clean up all the dirt and all the cobblestone, etc. And now, apart from this tiny bit of spaghetti on the end here, which we'll fix, I even done the same thing on the other side. We have 2 identical clean wiring tunnels. And also an expanded crafting capability with more crafting co-processing units and more crafting storages. And we have a few extra, but these do need to be square. Actually, for now, just to use them, we can do this. Yeah, that should do it. Remember, the coprocessors is how many items you can do in parallel. And the storages is how big an item we can request in the machines we're about to build. And these should both be online, right? Yes, device online, and the other one is also online. Perfect. Don't you guys just love audio settings getting reset? Because I sure do. But I believe I got things back to the way they were. And now we're ready to get started. Just like the other rooms here, like chemistry, I'm going to put a terminal in the wall over here. And this should, of course, we're going to make it red. And this should make it easy to tell or to grab things that we're missing from our AE system. The first thing being facades to cover this up. And so yeah, applied energistics channels, that is always something that we are in need of. So I do want to mention a small change that we're going to integrate at some point. In fact, I've already started it over this end of the base. So back when we first designed the power tunnels, we currently have applied energistics cable running on top of the power cable. I think I've decided that we want to invert that, so we have the power cable on the top and applied energistics underneath. And it's a bit more flexible to do it this way, because normally you can be more flexible with the applied energistics cable than you can with power. Power is a bit more rigid in the way that you set it up. So at some point I'm going to have to switch all these cables around. And I'm not looking forward to that in this room right here. But one day I will get around to doing that. Anyway, so yeah, we have LUV power, as always, being supplied to 3 different sections of the room here. Disconnected for now, as always. And the first of the power connections we'll send into the wire factory. I do really like the look of this multi-block. It's a bit unfortunate that it's 5 by 3 by 5. Or wait, 3 by 3 by 5. Yeah, this is going to be a bit of a jigsaw puzzle in here because all the machines are different sizes. For consistency though, we're going to put the output bus underneath the machine controller, maintenance hatch on top of the machine controller, and I'm not too sure about this catwalk yet. We will decide on that later on. For now though, let's construct all the multi-blocks. EV energy hatch, and then input bus, muffler hatch, and the rest can just be casings, although it looks like I didn't craft enough. There is a minimum number of casings which you must meet for all the multi-blocks. In the case of the wire factory, I think it's 20 minimum casings, but this is the reason why I crafted more input buses, since we can fill the rest with inputs, and this will give us more space for patterns, which you'll see what I mean by that in a second. But yeah, the last 2 casings here should complete the multi-block. Yeah, it's quite likely that we'll add multiple input buses for every machine. I did just realize this was one too far forward for the plans I have for the room, so I pushed it back a block. And I also switched the input buses to underneath. It should be a little easier to wire this way. So now we are almost done with this. We are almost auto-crafting wires. The hardest part is really crafting the machines and planning their placement. So we should have some interfaces in here. You know what, let's take care of the power situation first. So this is LUV power, HSSG cable. Let's do insane transformer, LUV to IV. Make sure this is actually plugged in back here. Remember, it is disconnected at the source. So this is IV power, then we have an EV high amp transformer, IV to EV. Big dot is the input, so this has to face to the left. And then as we mentioned, we're just going to run everything at EV, so we can just go with some 16x aluminium cable and plug this into the energy hatch right here, which is, again, is EV. Always make sure we double check. And again, EV is pink. Okay, so that should get power. And the last thing is the applied energistics channels. So I added a new P2P here, which powers the terminal we just added today. And we also have another controller addition onto the main applied energistics mainnet, as we're calling it. And this P2P frequency is Autocraft 1. I think we'll have to add a few more today. We'll see. So on the input buses, all we're going to do is convert these interfaces into the thin interfaces and drop these on the inputs. And also, I think one more on the output bus as well. Again, ideally this is an ME output bus to output directly into applied energistics, but we don't really have the platinum for that. So we'll address that soon. We do actually need platinum for another machine today. And then what is the best way to wire this up? Probably underneath the power cable and just run it up like so. Yeah, that's probably the slickest way to do things. All of these should establish a connection. It takes a while in 1.7. There we go. So now that we have the machine set up, we have crafting storages and coprocessors on the same network, and we have something to convert into wire. So let's say we want to make 1x copper wire. We are going to have to do this circuit 1 inside the Wiremill. We do still need the circuit number, so I guess that's another reason why we have to add multiple input buses, but it's going to be copper ingot into wire. And we're going to double up this recipe. Let's do a full stack at a time. So 32 copper ingots equals 64 copper wire. We'll encode this pattern. And this pattern is going to go into the interface next to the input bus, which we should really get into the habit of naming, actually. I think is it the cutting knife that allows us to... Can we rename the interface? Oh yeah, we can. Perfect. Yeah, we will establish a naming standard right here. So this is a Wiremill. Let's go from the Gregtech machines and not necessarily the Gregtech++ machines. since some of them today are going to be single blocks, so we'll just go with what it actually does. Yeah, let's do machine name, then voltage tier, then circuit number, circuit 1, and I think that's all the information we have to establish here, right? And the benefit to naming the interface is not only is it more clear when we're next to the machine, it should also appear here in the interface terminal. So you can see here, oh yeah, this one is the unnamed input bus. There should be, yes, right here, Wiremill EV1. And we can very easily drop recipes in here after we encode them at the pattern terminal. And we don't necessarily have to go down to the machine to drop in the pattern. So guys, if you see me not naming things in future episodes, then call me out for it. It's one of those things that it's very easy to get lazy with or forget to do in some cases. It's definitely worthwhile though, and it will save us a lot of trouble down the line. So yeah, I think for the Wiremill we have circuit 1, we have circuit 16, and normally the strategy with, I don't think I've talked about this, the strategy with wires is wherever possible you normally want to craft the 16x wire. Even if you need like an 8x wire for example, since the 16x can be uncrafted in a crafting table into 1x and you get all of the 1x wire, the equivalent, and then the 1x can be crafted up in a crafting table which is faster than using the machine, and of course doesn't cost any power. So in fact maybe we should have encoded copper wire as, I'm about to write copper, we should have encoded this as 16x, Wiremill EV16. We'll optimize the recipes a little later on, but the last one we're going to add for right now is circuit 3. And this will do fine wire. This does regular ingot into fine wire. So the last one will be Wiremill EV3. And then the output buses here we don't need to name. This is just to collect the output. And we'll make sure we hide this from the interface terminal. And that right there is the Wiremill done. Well, the initial setup is done. We're going to be adding to this throughout the rest of the series, I suspect. So let's do some maintenance. It should be running fine. And let's do our first test of copper wire. And of course, remember to plug it in here. No explosions. No. We're good, we're good. Okay, let's request copper wire. And let's do like 1,000 copper wire. It's gonna oh, we're actually missing copper ingots. Let's not do 1,000 copper wire. We have plenty of dust, and I think we should have like chalcopyrite as well. Maybe if we search Cu. Yeah, malachite, all of this smelts into copper. And then purified chalcopyrite and purified tetrahedrite. I've been saving this for platinum. But if it really comes to it, we might convert this down into copper ingots. For now, let's do 512 copper wire. That is 256 copper ingots. Let's see how fast this goes. Okay, run down to the machine. I might have to turn it on, in fact. Did it fill the bus? It filled the bus. Okay, let's turn this thing on. Oh, yeah. Oh, yeah. Now that is some rapid copper wire. And that was 32 at a time, right? I'm pretty sure, yeah, we got all 512. That was 32 copper wire at a time. Oh my goodness, what an upgrade. Yeah, look at this. As you can see here, it's 200% faster than using single blocks of the same voltage. And it only uses 75% of the EU per tick normally required. And on top of that, yeah, processes 4 items per voltage tier. So this is the reason we switched to GT++ machines, and not just spam a bunch of single blocks. There is definitely benefits to doing these sorts of machines. Oh, I'm excited about this. This is awesome. But this is only the beginning, right? We still have some other machines to do. Yeah, so from here I went ahead and constructed the industrial material presses for the bending machine and the forming press. The other 2 multi-block machines which we currently have crafted. I also spent some time developing the aesthetic of the room, built some more machines, routed some more cable, and just generally developing and upgrading the capability of our trusty applied energistic system. Alright, well, years go by, yes indeed, but we now have one of my favourite rooms in the base. Or you know what, it's pretty difficult to top the rocket silo here. But yeah, we also now have the forming press and the bending machine. Yeah, forming press, bending machine. On the other side next to the Wiremill, we also now have the polarizer and the lathe. Polarizer EV and lathe EV. And these ones are a little bit different in that there's no dedicated output bus. So for these we have to find the output hatch of the machine, or the output side of the machine, and click with a screwdriver to enable input from output side. So items can flow in and out of the same side of the machine. Point that towards the interface, and enable automatic output, which it looks like I've already done here. And yeah, it's really just as simple as that for the single blocks. We also give them power, of course, as well. And so now let's say we want to do magnetic neodymium. Let's do this recipe like 8 at a time. This is just a single block, so it doesn't parallelize any of the recipes. Might as well also encode the steel rod recipe here as well. I don't know how we're going to handle doing the recipes. I think most of them I'm just going to do off camera. But yeah, we could basically just stand here for hours and just encode recipes. There's thousands of them. So I think the best way to approach this is just to add them as we need them. But let's just do the first 2 here for testing, so these go in the interface, of course. Okay, I don't see why this wouldn't work, but just for my own sanity, let's request magnetic neodymium rods now. And it should send them to the machine. I already hear it. Yes, perfect. And yeah, as you can see, it automatically outputs to the interface, and it should clear the CPU on our crafting grid. Crafting status. Nice, this is exactly what we want to see. And it normally does it automatically, but we should be able to see here. Yeah, it's this one that took the craft. I think by default it selects the biggest CPU available. But for example, whenever we request an item, we can actually choose which CPU we want it to use, which is another pretty handy feature of Applied Energistics. But yeah, at the moment we started with the easy stuff, right? This is all stuff which is basically just item in, item out, with a few edge cases like the circuit numbers and the forming press molds, which we'll get onto later on. But what is going to happen when we try to request, for example, a machine hull? The machine hulls, the most efficient way to make them is in the assembling machine, and this most of the time takes polyethylene, which we have invested a lot of time into getting automated here at the chemistry room. We have polyethylene, we have polytetrafluoroethylene, which is used for the IV and LUV machine hulls. And then once you get up to ZPM, it takes polybenzimidazole. You guys will probably correct my pronunciation. But in any case, we can't really make the ZPM yet because this takes iridium. So we're not quite at that stage yet, but anything before ZPM we have covered in terms of the fluid. But how do we deal with that when we want to autocraft? Well, this is where we can make use of some new features in 2.3, mainly the mod AE2 fluid crafting, unsurprisingly. However, we do not yet have an assembly machine here crafted. For the assembly machine, there is of course multi-blocks we can craft. Well, we can't yet craft because they're way too expensive for us at this point in the game. The assembly machines though, I don't really want to be working with the single blocks. So what we are going to do instead is craft a processing array. One of these things, which is one of the reasons I mentioned we need platinum. It is quite a hefty amount of platinum and a lot of circuits for the Lapotron chips. And naturally, we are going to craft 2 of them, since I would also like to get a precision laser engraver, which is in the clean room here. However, these things you cannot automate because you need different lenses depending on the recipe, and you can't extract these automatically. So the best way to get around that is to craft the multi-block and then use different input buses depending on the lens. Similar to what we done over here for the Wiremill and the different circuit numbers. And that is also another advantage to the processing array for the assembly machine, rather than doing it through single blocks. So checking back on the initial list, let's do the assembling machine and the laser engraver. So 2 processing arrays. And I wonder if we can get the multi-block extruder as well. That would be kind of ideal. We use a lot of rods and that is probably one of the priorities. Okay, Inconel 690. This is going to be a complicated, yeah. Chrome, niobium, nichrome, molybdenum. I mean, it's not too bad. What is the casings like? Talonite and more Inconel? And Stabaloy? Talonite is this one... I'm a little concerned about our chrome supplies, to be honest with you. I crafted a lot of stainless steel. Yeah, it's not looking too healthy right now. How much ruby do we have? Oh, not bad. Over 1,000 ruby. If you count the gems as well. We can electrolyze ruby into chrome, right? Yeah, you know what? let's also add this to our list. So we'll also add the extruder. So that's the extruder and then 2 processing arrays. Yeah, easier said than done, but I guess we've got some more crafting to do. And then we're going to check out some fluid automation. Alright, so fluid crafting is going to be a bit of a learning process for me. I've never played with it in this specific configuration. We did play around with fluid crafting in All the Mods 7, but that was in 1.18 version of Applied Energistics. Here in GTNH it does work a little bit differently, but we now have our 2 processing arrays. For now the ABS is going to stay in place, and we're going to place our 2 processing arrays here and here. Yeah, this will be for the laser engraver and the assembling machines. And also maintenance hatches, we don't need mufflers for these. Alright, for now we're going to leave them as a shell. I do have the rest of the casings here, but it kind of depends on how the fluid crafting works. We'll have to figure that out in a second. But for now, let's also build the extrusion machine. And to do that, we're going to need TPV alloy, which in fact is what our blast furnace is made of, but we have never made TPV before. Until now. You're probably thinking, how's that possible? Yeah, these pink coils here were automatically converted when we updated the pack. So we didn't actually craft this thing, but we do need it for the extruder. I believe we specifically need it in wire form. I don't know why I'm doing it in the single block. It's gonna take a while to get used to all this stuff. But when I was crafting these machines, I did add a few more patterns. I've just been trying to add them as we need them. Things like tungsten steel, things like electrum foil, a few other wire recipes here and there as well. But yeah, this should give us the ability to make the advanced extruder, IV, and then upgrade that into the multi-block version, which is also potentially a quest. Yes, Play-Doh for big boys and girls. I like the name of that quest right there. And the extruder is going to go next to the wire mill here, and we'll have them in a triangular pattern, because this one is also 3x3x5, and then the single blocks will go in the odd spaces, and eventually be replaced with that, what is it called? The large processing factory, the one we can't build. This is 3x3, so it should fit in these spaces here, and as we eventually swap them out and gain the ability to make this thing. So yeah, extrusion machine right here. Alright, that should be the multi-block built, right? I hope so anyway. Again, we're running this thing at EV. Yes, complete structure, perfect. Okay, so this thing has a lot of extra setup, which we're going to take care of next episode. For now, we are going to investigate fluid crafting. Okay, so there is a quest here for it in the Applied Energistics chapter, and by the looks of things, we need a few extra components to make this work. The first of which is a fluid pattern terminal to encode the recipes. Yes, device online. Okay, perfect. And this looks almost identical to the regular pattern terminal. I wonder if we can just change it out. I don't see why not, right? Can this also do regular patterns? Yeah, I'm going to assume that's just an upgraded version, so I guess we can just remove the regular pattern terminal and replace with the fluid variant. Okay, we also need something called a fluid discretizer. Discretizer? Am I saying that right? Probably not. We're missing an EV pump. We can craft one of those. So I read the tooltip on this thing a few times. It registers fluids as items in the Applied Energistics system, but it doesn't actually convert the fluids to items. It's just for the purposes of pattern encoding and sending the fluids to where they need to be. It basically treats it as an item, and will send it as a fluid. That might sound a little bit complex, but I think it's actually easier than it sounds. This just has to be on our network somewhere. And I guess it makes sense to put it below the terminals down here. I don't know if we have enough channels here though. Yeah, let's drop it down right here. And is there there's no GUI for this, okay. We are also going to need a dual interface, which we have crafted before, but we used it to craft the ME output bus. We need these for their intended purpose though today. No, one more thing, we also need an ingredient buffer. It looks like there's 2 different versions, a large and a regular. Can we make the large? No. We'll go with the regular right now. Okay, another fluid processor, a cell workbench. And we should have the rest of the items. Yes, ingredient buffer. Okay, so I think it would be... Oh wait, that's interesting. Look what I've done to the fluids. I guess it does this... Can we take these out? Wait, what can we... Wait a second. Drop of oxygen gas. Can we do anything with these? I was under the impression it could only... it was only for Applied Energistics to use. And we wouldn't have access to these drops. But yeah, this corresponds to the fluid storage that we have on the network. You can see here water, sulfuric acid, hydrogen, mercury, and oxygen. let's try to simplify things as much as we can, and we're just going to be working with the machine hull recipe. Right, so the ones we showed before, let's make it our goal to autocraft the LV to EV machine hulls. And for that we do need polyethylene available to our system. So we are going to have to find polyethylene back here, and we'll have to add a fluid storage bus. I really hope we have enough channels down here. So let's plug this into the polyethylene tank. Always make sure we partition. And also I was thinking about this a little bit, it's quite possible that we switch away from fluid P2P, but I'm inclined to keep these in and just use both. And the fluid P2P, by the way, won't work for fluid crafting, because it doesn't expose the fluid to the network. It's just a way to send fluids through a tunnel using the Applied Energistics network. But like, for example, I don't know, butene doesn't have a fluid storage bus on there, only a P2P, and therefore it doesn't show in the fluid terminal here, unlike polyethylene, which now shows up, which means that we can now add recipes for all this stuff. So we want to encode the machine hull. Shift clicking gives us the fluid and not necessarily the drop. I thought I would have placed the drop in here, but I'm going to trust that shift click works. Let's encode this. Oh, it gives us a different color as well. Okay, interesting. I have some assumptions about the way this works, but let's see if my theories are correct. We are going to have to build the processing array, and we'll have to also give it an input hatch for the fluids, along with input bus. The output bus should be on the front there, and the rest is just going to be casings. Okay, as with any other processing array, we also need a machine to put inside, since the processing array is just a shell for us to be able to run pretty much any machine we want, and I think we're going to run at EV. I mean, we can't go any higher because of the power we have connected to the machine. So let's for now grab this EV assembling machine, which has been desperately needing a home ever since we built it, inside the processing array here. Okay, let's do some maintenance. Oh, I also, by the way, added these doors in the side, just as maintenance access, and same on the other side here. It's just those tiny little details. We might, by the way, have to extend this wall back a few blocks. This maintenance hatch might get a little crowded, especially when we maybe have to add hatches on this side of the machine. Anyways, for now on the processing array, we'll give the interface for output. And instead of the regular interface, we're going to use the dual interface. And this thing we're going to place on the input bus. Wait, I think we can place it on either one. And of course, we're going to give it a name. Let's call it Assembler PA EV. And it may or may not get a circuit number. It kind of depends on recipe conflicts. For now, we'll leave it without a circuit number. So that should send the items into the bus, but we need a way to get the fluids into the hatch, right? And for that, I think we can just use a Gregtech pipe. That was weird. Or wait, this is where the ingredient buffer comes. Wait a second. Can you tell this is the first time I've ever done this? Okay, and we cut out like 5 minutes of me fumbling around with this thing. I think I've got it figured out. So we've got dual interface into ingredient buffer, then into fluid pipe. And then we'll also have to introduce a conveyor and a pump. And actually thinking about this a lot, there's not necessarily one way to do this. I've been told that you can do it with subnets, which we might implement down the line. Let's rename this since we broke it. So yeah, we've got interface into ingredient buffer, which buffers the fluids and the items. And then we have conveyor on the input bus here, set to import. And then a pump on a fluid pipe into the input hatch here. And the dual interface here gets the pattern. Dual interface, of course, can handle items and fluids. So now, once we request the LV machine hull, if I spell correctly, it's not requestable. That's not a good sign. Things plugged in here, things are offline. Things are offline, that's not a good sign. Oh, I didn't link the P2P. This is going flawless, guys, don't worry. But it's all part of the fun, it's all part of the fun. Okay, this should get a frequency anytime now. Yes, device online. Now when we request the LV machine hull, we're missing the machine casing, of course we are. In fact, this is also an assembler recipe which needs circuit 8. We might be able to also encode the circuit 8 recipe. And I think we should just be able to double up this input bus as a circuit 8. It shouldn't have any conflicts, recipe conflicts, and we'll just do both of them in the same input bus. And we'll give this an 8 on the end. So now it should handle both recipes, right? It's going to make the machine casing, and then send it back into the input to make the machine hull. Let's try this recipe one more time. Okay, so LV machine hull, yeah, it's gonna craft both versions. I think we'll have to turn this on. Okay, nothing is happening. That's not a good sign. We got the steel plates in the ingredient buffer. Is this just pointing the wrong way? Oh, I just realized. It took me so long to... I just realized... Look at this. I got the conveyor, which handles items on the fluid pipe, and the pump, which handles fluids on the input bus. We'll have to swap those around. Oh, so many fails today. So many fails. Yeah, we want the pump on the pipe, and the conveyor module on the input bus. Now it should let the items in here, right? Once we enable import. Yes, there we go. Okay, the machine should turn on. Yes, and it made the machine casing, got instantly sent back to the input bus. I assume it consumed the polyethylene there. And we should see a cleared crafting screen. Yes, we do. Perfect. And we have 17 machine hulls. Nice. Yeah, so that did take a while. Hopefully you can see how things are going to scale from here. Let's also encode the rest of these patterns here. There is also the wrench recipe, but where possible you want to avoid tool recipes in applied energistics. Sometimes it's okay to do it, but for the most part you want to do it in the machines. Okay, so MV, HV, EV, and then same for the machine hull recipes, which do import polyethylene. Alright, so there is still lots and lots to do here in Autocrafting land. We still have the laser engraver to set up, although it's mostly done. We still have to configure the extruder. And we also have to configure the forming press, this one here. But like 60% of the hard work is already done in that regard. For now, to close out the episode, just so we don't get too far ahead of ourselves, I would like to fix the system we built in the previous episode. You guys had some great suggestions on this processing array. Okay, so basically the issue we were having is trying to prioritize the usage of this wood tar. We want it to use this wood tar before it makes any fresh from the ICOs. So the simple fix is to remove the P2P on the output hatch, replace this with a super tank buffer, and this is going to turn on, very loud. Let's give it a muffler. And this allows us to put a wireless fluid detector cover on this. We'll also have to find the ID of this, which is 429. This is just our way of naming the frequency. So it's going to be frequency 429, inverted. And then whenever it has 2 buckets, or under 2 buckets because it's inverted, then we want the ICOs to turn on and make some more. So to do that, we can add some machine controllers on the side, and also the wireless receivers on the output bus, which is connected to the machine controller. This will also be on frequency 429 and on analog mode. And then, as always, redstone on, machine on, and safe mode. And they're not turning on right now because we have, we're not using void excess, and this output hatch should be full. Yeah, and this wood tar here is sent directly into the distillation towers, which distills into benzene. And we want to keep it that way, right? We don't want to send the output of the ICO into the super tank. So we need to make sure we disable the input from the output side, and put this P2P back, plug it back in, and bind this to the wood tar frequency, and we'll select this to automatically output. So again, effectively what we've just done here is we're making sure that this is used first, since the hatch on the ICO, which is the primary producer of wood tar, will empty out, and it won't make any more until this tank here reaches 2 buckets, in which case these machines will turn back on, fill up their hatch, and be sent to the distillation tower to be distilled. And yeah, this also means that we should have a bigger buffer of wood tar. This is just going to it's a very slow recipe here. This is just going to slowly make us more wood tar. And the distillation for benzene is very fast, so we're effectively buffering more benzene like this, kind of. Yeah, pretty simple fix overall. Thank you guys for your suggestions. Oh yeah, and I also followed another suggestion and converted this to brown. It was previously blue. Yeah, what do you guys think about this? I actually really like the usage of brown in here. It kind of works for benzene, even though that's black, but close enough, right? Anyways, with that, I think it's also a good point to wrap up the episode. We made a really great start on Autocrafting. Of course, we could do this for tens of hours, hundreds of hours still. Yeah, there's still lots for us to expand here. We'll probably be doing this for the rest of the series every now and then. But for now, that is going to do us. Thank you guys so much for watching, and I hope to see you all in the next episode of New Horizons.